So what's being depressed? Sorry if you're jumping in right now. I started that late. What's being depressed? Come on, people, fast. That way we can move. Cover your schnoz. What's being depressed? Jerry? His line of sight. Normally, we're going to look out over the horizon, but then all of a sudden, he had to look down. He had to depress his eyes, go down, to spot the Roadrunner. And so if you look, that clearly tells us he had to look down. So this is how much he looked down. That is the 10 degrees. You don't just make a magical triangle and shove the 10 degrees somewhere in your magical triangle. There are no magical triangles in real life. Period. They're there because we make or imagine them there. And we have to understand how the pieces fit. So we know that's 10 degrees. And then it's asking us, hey, how far is the Roadrunner from the base of the cliff? So I'm going to put that, we'll call that B for, distance from base of cliff. Could have called it R, could have called it anything I want. What questions might we have about my pictorial setup? Because it's important for us to know what it looks like. So, on the homework quiz corrections, a lot of us had this part correct. We had corrected this aspect. But so many of us are now like, oh, I got to find B. Let's just put some things together and I'll magically have B. Stop it. Don't do that. Okay? So, if I look at this, I want us to keep, what do you notice? What do you know? How might we be able to find B?
That 10 degrees. So you can't measure anything with that right there. So you gotta put it at the angle where the Roadrunner is, because those two are, I don't know what you call them.
Alternate interior angles. Yeah. So if we look, we've got this transversal line right there, and then we've got these parallel lines right there. So if you go back to geometry, alternate interior angles. Okay? So yeah, we can definitely put the 10 right there. That's one way we can handle this. This is one way that we can handle this. There are others. I could have made a triangle out here. It's the same triangle, kind of, right? Same sizes. I just have to label those sides, and now I'm good. I could have also been like, well, I know this angle is 80. And I could have worked from 80. And I wouldn't have needed to work from 10. I have options. But Mitchell picked, so we're going to go with Mitchell's. Here's where the big mistake is. A lot of us are trying to instantly come up with the expression for B. We're doing it all in our head. Stop it. Okay? Put it down on paper. If you can see it in your head, put it on paper. So what is a connection between the information that I have, which, is here and here, and the information that I want, which is here? What's the connection? What do you see? And I see that this is the opposite side, and this is the adjacent side, so it really looks to me like a tangent ratio, which means I can set up my tangent ratio. So I'm going to go ahead and I'm going to set that up physically. I'm not going to do it in my head. I cannot stress this enough. Tangent of 10 degrees, so I'm looking from this angle, okay, is, right, because the tangent of an angle is going to be our opposite over our adjacent. So it is 25 over B, right? Because it's the opposite over the adjacent. Tangent of 10 is 25 over B. Those of us that are trying not to set up the equation or solve it in our head, you are making a mistake. Out of curiosity. Now, I made a picture. I know what it looks like. Great. I talked about what I wanted and what I'm trying to find, and I labeled everything. It's awesome. That's my help yourself sign up there, right? I made my equation so I can see it, right? This is what the ratio looks like, so it's not floating around in my head. Great. Now I know exactly what I need to do. I need to find B. And here's the mistake. This is a mistake. This is a big, fat no. This is the mistake that I'm seeing. People are multiplying both sides by 25. That is a big, fat no. Why? Fairly. Right. That won't cancel out the 25. How is the 25 connected with B? Or what does multiplying by 25 actually cancel out for us?
Dividing by 25.
It would cancel out a division by 25. Multiplying by 25 is the opposite of dividing by 25. I don't see divide by 25 anywhere. So I need to cancel out what's there, or I need to make it prettier. And I do this a lot. Like, I'll ask myself, what's ugly? Or what don't you like? Okay, and then we can fix it. So for some of us, we're like, I don't know what to cancel out. Okay? So just be like, all right, look at that. What's ugly? What don't you like? Literally, just describe what you don't like about that equation. Gabe?
I don't like that there's a variable on the denominator.
I don't either. I hate the fact that B is in the denominator. So let's take care of that. How could I get rid of that B in the denominator? Yeah, Trevor.
Multiply both sides by B.
Yeah, I mean, multiplying by B will cancel out dividing by B, right? Those are the opposite. That's beautiful. Maybe it's not solved, but it's prettier. I'm more comfortable with it because now what we're going to have is B times the tangent of 10 is equal to 25. I am much more comfortable with this equation than I was the first one. And now again, wait, what was I solving for? Oh, that's right, B. So what do I want to get rid of? Tangent. How is tangent connected to B? It's being multiplied. So now I can use division to cancel out that tangent of 10. And I'm going to be left with B equals, I'm going to do it down over here, 25 divided by the tangent of 10 degrees.